This is the best image from the asteroid Eros. Compared to that of Itokawa. And this is the pavement behind Johnson Space Center with someone's boot for scale. Just to give you an idea of what the surface was like. This is very similar to very smooth gravel. What you have on Earth. Not the same, but similar. Okay, so let's talk about Hayabusa 2. Another JAXA mission. This was launched December of 2014. Arrived at the asteroid in June, this June. Planned to leave December of 2019 and return to Earth December 2020. So the target of Hayabusa 2 is asteroid Ryugu. So here's a slide comparing Itokawa versus Ryugu. And you can see several differences. One, you notice that the spin rate is different. The size is also different. The brightness, or what we call albedo, is different. Itokawa is much brighter, 25%. Ryugu, at the time we thought, was only 7%. We think now it's actually darker. The type of the asteroid, in terms of its composition, is different. S versus C. Silicate rich versus carbonaceous. But both Apollo near-Earth asteroids. You can see the orbits here. Notice they cross Earth's. Both potentially hazardous. Just a little bit about the spacecraft. Solar powered, like Hayabusa. New antennas. This is the sample horn. This is the area you'll see later that touches down on the surface of the asteroid. Here is the backside of Hayabusa 2. Here is the ion engines. This is where the mascot lander. Minerva rovers. Again, the sample horn and the target markers. And very exciting is the small carry-on impactor, SCI. You will see this all in action in the video. So here's the video of Hayabusa 2 approaching Ryugu. Again, this is before we knew what Ryugu is like. This is how the target marker is deployed to the surface. And the target marker helps the spacecraft navigate down to the surface. Hayabusa 2 touches down, fires a bullet, picks up the material from the asteroid, and lifts off. Now we have the deployment of the small carry-on impactor, which will be very exciting for many reasons. The spacecraft does not want to be near the small carry-on impactor when it explodes. So it hides behind the asteroid. The small carry-on impactor explodes, and drives a copper projectile into the surface of Rudu to make a crater. We would like to take a sample of that exposed crater material. The reason being is we think maybe there are differences between the surface and the bottom part underneath of Rudu. So it takes a sample in much the same way. We are looking forward to this very much. Okay, OSIRIS-REx, NASA mission. It was launched in September of 2016. It arrives, where I get to. Tokumo Oki. Depart March 2021, and then leaves, or returns to Earth, I should say, September 2023. This is what we thought Bennu was like. In a radar image, not so good, of Bennu, but we could make maybe a model of the shape. Keep in mind, look at the shape, and then think about what you see when you see Rudu. Also, half the size of Rudu. Rotates maybe twice as fast as Rudu, but maybe very similar, not identical, but very similar to Rudu's composition. So this is the principal investigator of the OSIRIS-REx mission. He's very happy. This is his spacecraft. OSIRIS-REx is what we call an acronym. It stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. It's a big name, but OSIRIS-REx will do many things at Bennu. So here's the spacecraft at the Kennedy Space Center before it was put on the rocket. You can see how big it is when you compare the size of the spacecraft to the people there. Here is the spacecraft. This is the antenna that communicates with Earth. This is the sample return capsule that will bring the samples back to Earth. And then several scientific instruments that will take images of Bennu and figure out where to go to take the sample. This is a video of the launch of OSIRIS-REx. Please enjoy.